At this point, we are starting to get a clear picture of how UCS does networking. We understand how the fabric interconnects switch traffic. They're not running as pure switches, they're running in end-host mode. And now we've seen that the VICs create these vNICs that we extend down to the virtual hosts. And those virtual hosts now can switch across many different vSwitches up through these vNICs. But we're still missing one important component to all of this, and that would be how exactly does the traffic get from the vNICs up to those fabric interconnect uplinks? So in this video, we're going to finish up our conversation by really gluing this all together and seeing how the end-to-end traffic flow goes all the way from, again, the uplinks of the fabric interconnects down to the vNICs inside the servers. Let's take a look. So here we have the beautiful UCS architecture. We've got our LAN cloud connecting down into our fabric interconnects here. The fabric interconnects are typically going to connect to I/O modules in the back of a chassis. That's why we have the I/O modules drawn here. But in the event that this blade down here is actually a rack mount server, we might be connecting through fabric extenders, or we could directly connect to the fabric interconnect. Either way, whether these are I/O modules or whether they're FEXs, this is going to be a pass-through concept. We don't need to worry too much about these as far as the networking is concerned. The main thing we need to understand is that they're incapable of switching traffic, meaning they have to send all of their traffic up to the fabric interconnects in order to get switched. So we're not going to see anything like this, where the traffic comes up, hits the I/O module, flips around, and comes back down. That's not possible because the I/O modules, again, are not capable of switching traffic, so make sure we understand that. Now, what we have drawn out here is we have the physical world in yellow, and we have the virtual world in blue. And so we need to connect into this virtual space, and the way we do that, we recall, is with this VIC. The VIC is going to carve up multiple vNICs, and so I'm just going to draw them like this, where the vNICs are showing up inside the physical space, which I suppose is appropriate because they're not physical, they're virtual, and so the virtual world now sees virtual NICs, these are the vNICs, that are created inside the VIC. And by the way, we create these inside of UCS Manager. So in UCS Manager, we'll see this concept of service profiles that we've already talked about. As part of the service profiles, we specify the number of vNICs that we want. And so in this case, let's say we've created a service profile, we've applied it to this blade, and we specified that we want 4 different vNICs. So now we have these 4 different vNICs, and we connect them in like this. We've got 2 of those connections going to the vSwitch on the left. This maybe is a data vSwitch because we are connecting our virtual machines to it. But then maybe the vSwitch on the right, this is a VMK-based vSwitch, so we're going to be doing something on here, whether that's iSCSI or live migration, or maybe even management traffic. But either way, we're bringing those other 2 connections into the vSwitch on the right. But here's the question. How does the traffic down here in the VM space get switched up through this process all the way to the physical network? And in order to understand that process, we need to understand how the vNICs are going to get switched. Because in the networking world, if we have a physical server with a physical NIC on it, and that physical NIC is connecting to a physical switch port, well, we know how to configure that. We can get onto the switch port and we can do configurations here. We might say interface Ethernet 1/1, and we can do a switch mode access or switch mode trunk, and we can do all of our configurations just like we're accustomed to doing. However, how do we apply that level of configuration if this is no longer a physical NIC, but now it's a vNIC? Well, it's kind of cool how Cisco decided to do this because they're effectively going to maintain this architecture. But the way they do that is with the concept of a virtual Ethernet port, otherwise known as a vETH. This virtual Ethernet interface is going to live inside of the fabric interconnect. And it's interesting because the virtual nature of the vETH makes it feel like an SVI. It's going to live inside the fabric interconnect. However, the ETH part of the interface makes it feel more like a physical Ethernet interface. Because again, over here on the right, we've got these configurations that we're used to, like switch port mode access and switch port mode trunk, like we said, and that's going to apply to a vETH port as well. And so the concept is this. This vETH port is going to effectively be connected down to a particular vNIC. This vNIC is attaching to a virtual Ethernet interface, and any configuration that we want to apply to that vNIC is going to go under the vETH port. Now that said, while I'm trying to drive home the point that this vETH port gets configured like any other interface, and so I'm likening it back to the CLI and such, but we understand that in UCS, this configuration appears in UCS Manager, not via CLI. Now, if I'm on a traditional NXOS switch, I absolutely can create vETH ports. I can use technologies like adapter FEX in order to spin up vETH ports and connect them down into the virtual space. At which point I'd get onto my vETH port and I would configure it again using these traditional CLI commands. However, we're not in NXOS world. We're in UCS world, and so all of our configuration is going to be done via UCS Manager. That said, however, we can get onto the Fabric Interconnect CLI, and even though the CLI is going to feel a little bit unfamiliar to us at first, it's got its own set of commands and such, we do have the ability to type connect NXOS. Because remember, we are running NXOS under the hood, and as a result, we can connect to the NXOS instance. And once we're connected, we can do show commands. We could do a show run, or we could do a show run interface vETH. And these VETH ports, by the way, they're not numbered like 1/1 like we're used to. They are numbered sequentially. So we might have an interface VETH port 110. Again, no slashes or anything, just a straight up number. And when we do this, we see this configuration. UCS Manager has asked us, for example, which VLANs to apply onto a vNIC and what's the native VLAN. And so that's going to show up as the traditional commands that we're used to. We're going to see switch mode trunk on this VETH port. And then we're going to see switch port trunk allowed on here, telling us which VLANs are allowed, as well as switch trunk native. Because again, we can specify a native VLAN on that interface. So even though we don't directly configure this, we do it via UCSM, so it's a little more indirect, the result is the same. So the driving point in all of this is I want us to start thinking about these VETH ports as if they're physical ports. A VETH port connected to a vNIC might as well be a physical Nexus port connecting to a physical NIC. Now I'll add one quick thing on here, and that is somehow these VHBAs always get the raw end of the deal, and they're barely hanging on to this VIC in my drawings. But either way, if we were to connect VHBAs here as part of our fiber channel environment, then the same concept's going to apply, where the VHBA gets bound up here to a virtual fiber channel port. And so we have VETH ports and we have VFC ports on our fabric interconnects. But we will be talking in more detail about the storage networking of UCS in a future video. So now that we understand VETH ports and how they connect down to the vNICs, we need to understand which of these vNICs are attaching to which fabric interconnect. Because when we look at the vSwitch on the left down here, we've got a vNIC that's connected up to fabric interconnect A right now. Well, for redundancy's sake, if fabric interconnect A were to go down for any reason, we'd probably want the other vNIC to be attached to fabric interconnect B. And that would be a perfectly valid configuration. Ideally, this is what we have going for us. And so the same thing on the right here, we have a vNIC that's attached to fabric interconnect A, and we have a vNIC that's attached to fabric interconnect B. And so as a result of this configuration, we should see that we have two VETH ports on the left, and we have two VETH ports on the right. And that's because two of the vNICs are on the left and two of the vNICs are on the right. And this does bring up an important point, by the way, and that is that any vNIC at any time is only attached to one fabric. And let me write that down because that's very important. One vNIC is attached to one fabric at any given moment in time. And that's the key word right there, at any moment in time. Because we do have another concept that we need to discuss, which is the concept of vNIC failover. vNIC failover allows us to tell UCS that, hey, if for any reason fabric interconnect A were to go down, I want this vNIC down here that is riding on fabric A to swing over to fabric interconnect B. Because this VIC in the middle, it has connections to both fabrics. And so there's no reason why we couldn't just swing that traffic over in hardware. For the VIC to say, okay, fabric interconnect B, now you're receiving this traffic because fabric interconnect A went down. So in UCS Manager, when we're configuring a vNIC, we have the failover checkbox. We say, do we want it to fail over in the event that the fabric goes down? And we can check that box or we cannot check that box. Now, in order for this configuration to work, we actually need a VETH port on fabric interconnect B for the failover vNIC. This VETH port is going to be in a suspended state because we're not actually switching traffic while everything is under normal operation. However, in the event that it fails over, this VETH port will activate and we'll be able to receive traffic for that vNIC on fabric interconnect B. But the key here, again, I want to come back to this concept right here, is that regardless of the failover scenario, we are only attaching to a single fabric at any given moment in time. We might be on fabric A in normal operation and we might fail over to fabric B, but when fabric A comes back online, we're going to fail back to fabric A. We're not load balancing traffic between these fabric interconnects. So here's the question for us. Should we always enable vNIC failover? And I'm going to tell you flat out, the answer is no. We should not necessarily check that box. And the reason for that is we should have redundancy even if one of the fabrics goes down. In other words, why would I have two vNICs here in my virtual space if I'm just going to use failover? If I have vNIC failover enabled, this hypervisor will never see either of these connections ever go down. They'll both be online fully, even if fabric A were to go down for any reason. Furthermore, we think over here on the right with iSCSI. I mean, we've got multiple traffic paths and we've got multi-pathing enabled. Do we want to use vNIC failover or do we want to rely on the different fabric paths? And depending on how we've configured our networking up here, maybe failover isn't even going to fully function. And so we do have to be very careful with this configuration, understanding exactly what it is. I will say that in most of my UCS deployments, I did not use vNIC failover. Because in most virtual applications, and in a lot of bare metal ones as well, we've got redundancy built in to the pathing, to the vSwitches. We've got so much redundancy at the application and virtual level that we don't necessarily need it in the hardware level. But that said, that option does exist if we need it. So with that, we have now the complete picture of how networking works inside of UCS. First of all, the physical connections. We know that in the back of the chassis, we've got I/O modules. Potentially our rack servers are going to connect up to fabric extenders. Either way, the physical connectivity does go through these devices. However, those are in pass-through operations, so we don't need to consider them as if they're real switches and capable of switching. And now we see from there that the vNICs, they attach to the fabric interconnects via those virtual Ethernet interfaces. And so those virtual Ethernet interfaces connecting to virtual NICs, they might as well be physical Ethernet connecting to physical NICs as far as our network mentality is concerned. We apply a lot of the same configurations, even though we don't do it directly via CLI, we do it in UCS Manager. Now, lastly, we talked about failover. Failover is an important concept. We've absolutely got it as a tool in our belts, but before we enable it, we need to understand what it's doing. And what it's actually doing is it's going to build a second virtual Ethernet connection out to the other fabric interconnect and swing traffic over in the event that we're having problems. And so the question is always, do we want the application, do we want the virtual host to see the failure? If we do want it to see the failure so that it can do its own handling of that situation, then we should not enable failover. If we want it to be invisible to the downstream host, if we never want the host to see an upstream failure, then we'd enable failover, and at that point our two vNICs would always stay online. I hope this has been informative for you, and I'd like to thank you for viewing.